Let's explain you a vector database in a simple form. So I found this article on the internet and I can explain you everything from beginning to end. So if you have just recently heard the term of vector database for the first time, you are not the alone. Although the vector database around for few years, they have recently drawn the wider developer community attention. Means vector database have created 2-3 years ago. If you are here vector database recently, you are not the alone man. There are many people that will listen this first time. So what is the great about this? So when the ChatGPT is released on 2022 December, the public understand the capability of the state of large language model, while developer realize that vector database can enhance this model further. So this article will explain some of the core concepts such as a vector embedding and vector search. Then we will dive into the technical detail of using distance matrix in vector search and vector index enable efficiency. Once we have fundamental understanding, we will discuss cases and code to landscape. So here we can get the definition of vector database. We can see it. So the definition we can read it. A vector database means simply it can index long PDF into make it chunk and convert into binary form of data and store in cloud or anything, and then it can find out relevant. When we search the information, that can it provide relevant information on that, not from other side of thing. Like when we use ChatGPT to upload PDF and ask a question, it can't give accurate answer from our PDF. It can also use sometimes internet or on database, but in vector it can use only PDF or anything that we uploaded. So now we continue the part. So here is the data. A vector database index, store and provide access structure or unstructured data, example text or image, alongside its vector embedding, which are the data numerical representation. It allows user to find retrieve similar object quickly at a scale in production. So we upload data something in a vector database. We need to find information that are similar to look like image or text. So we use vector database to find it. So it can index, store, provide access to the structured or unstructured data alongside vector embedding. It allows user to find and retrieve similar object quickly at a scale in production. Because of such capability, it is sometimes also called vector search engine. How do vector database work? Here I can find. So vector database retrieve data object with the vector search, vector embedding, which are machine understanding from a human understanding object such as text, image, song, video, and so on. Vector database also use index to retrieve data object at scale. This section is introduce the core concept of. We will discuss what is vector embedding. So this means vector database convert into chunk like binary form. Then it can allow us to find data in quickly and fast way. So that is the part that can it explain. Now how do vector database work? So the vector database retrieve data object with a vector, search user vector embedding, which are the machine understanding format of human understanding data object, such as text, song, video. Vector database also use vector indexing to retrieve data object at scale. The section introduced this core concept will discuss. To vector embedding, how they enable similarity search and they are resilient. So when you use n8n to find a similar type of data, but it can take a lot of time. But vector database, this make a lot of easy. So it can convert PDF into machine understanding format of human understanding data object. When you use vector database to search, then it can search it in binary form and present in a text form. So here is the vector embedding. When you think of data, we are probably think of natively organized human number in a spreadsheet. This type of data is called structured data because it can easily be stored in tabular format. However, image, text, example of document, social media post, or email, or the time of search data, example audio file, sensor data, or video. The problem with this type of data is that difficult to store in organized way, so it can easily find the what you are looking. So we make tons of PDF, book, audio, music, but what we need to find on the internet on our computer, that is too boring task. We can spend hours of our time to find, but it's not founding. So what can we do? We can upload the data in our vector database, then we use to find this type of problem. This vector embedding model solve, but involved in artificial AI or machine learning. UML have enabled us to numerically represent structured data without losing its semantic meaning. Is now called vector embedding. A vector embedding is a long list of human is describing a feature of the data object. An example is how we numerically represent color in the RGB system, where each number in the vector describes how red, green, or blue color is. Example: the following green color can represent as 62050 in the RGB system. You can see how the vector embedding model work. Now let's continue the again part. But filtering more complex data such as word, sentence, or text into meaning processes of the number isn't trivial. This is where AI model come in. AI model enable us to represent the contextual meaning. Example: a word as a vector because they have learned to represent the relation between different words in a vector space. A model that can generate embedding from unstructured data are also called embedding models or vectorized. Below you can see n8n example of the three-dimensional vector space of the RGB system with a few sample data. Let's explain with this. Here you can see there in this are three color, three lines, and this will be our cube. You can see green, blue, red. And this will be our line, and this will be. Now we need to find a color. different embedding model represent data in a different vector space. So ChatGPT can represent data in 72, Gemini can 72, ChatGPT have 1550, I think. Different embedding model are represented in different vector space. Vector space can different in the number of dimension, ranging from tens to thousands, where the precision of the represent increase with increasing dimension. In the color example, there are also different ways to represent a color numerical. For example, you can represent the previous green color in the RGB system 62050, means this is the color name, or in the CMYK system 9700120. This is why it is important to the same embedding model for all your data ensure in the respective vector space. Vector embedding numerically capture the semantic meaning of the object in relation to other object. Thus, similar objects are grouped together in the vector space, which meaning in the closer to object, the more similar they are. For now, let's consider a simple example with numerical representation of word, also called word vector. In the following image, you can see the word wolf and dog close each other because there are direct descent and of wolves close to the dog. You can see the word cat, which is similar to the word dog because both are animal. They are also commonly pets. But further away on the right hand side, you can see word that represent fruit such as apple or a banana, which are closely each other further away from the animal term. Let's see it. This is a wolf, dog and cat. This is category of pets, animal. But cat, dog and cat are domestic animals, so it can in the same bracket, not same, little bit closer. And these are the fruit category. You can see this can dimensionally in the fruits. Now explain with the vector search with the example of this. So vector search, vector embedding allows us to find retrieve similar object by searching for objects that are close to each other in the vector space. This concept is called vector search, similarity search or semantic search. Similarly to how we can find similar vector. For the word dog, we can find similar vector to a search query. For example, to find a word similar to the word kitten, we can generate a vector embedding for this query term, also called query vector. So, and return all the nearest neighbors such as word cat illustrated below. So we need to find kitten that are also name of cat, means cat, kitten is the baby. Let's see. This is the vector search, and the query search is will be kitten. The kitten will call baby of cat. So this is the similar search that it can provide us. You can see this diagram explain that. As the concept of semantic search is based on the contextual meaning, it allows for more human-like search experience by retrieving relevant search result that match the user intent. This is advanced mixed vector search important for application. These that are example of segmenting typo or synonyms. The unique represent of data object allow us to apply mathematical operation to them. For example, you can calculate distance between two vectors represent to them. For example, you can calculate the distance between two vectors represent to determine their similar. You can use several similarity measure to calculate distance between two vectors. Example, Weaviate support to the following distance metric. Calculate the straight line distance between two vectors. It range represent indirectly vector and large value represent mathematical distance. Calculate sum of the length of the projection of the line segment between the point onto the coordinate x. It range 0 infinity. Here 0 represent identical vector and larger value represent increasingly dissimilar vector. Dot product. Calculate the product of magnitude to vector and cosine and the angle between them. It range where 0 represent vertically vector and large value represent increasingly negative dot product give. You can see the example cosine dot क्या है. As you can see, there are many different similarity measure as a rule of thumb. Select the same metric as one of the used to train the ML. You can see it. Here's the cosine similarity or mini LLM to host it on a Hugging Face support cosine similarity dot product and equivalent distance to learn more about different distance metric. You can continue reading our blog post. Here are distance metric in our vector search. So when you want to find closest item to given query vector, the brute force approach will be the use of k nearest neighbor (KNN) algorithm, but calculating the similarity between your query vector even into vector database require a lot of computation resources, especially if you are large data set with millions or even billions of data points. This is because the query calculation increase in only 0 with the time initially. Means we have millions of text, PDF, audio. This is impossible to find anything. So this means possible, but it's too hard to find. Cost to maintain. So we use vector. A more efficiency solution to find similar object is an approximately nearest neighbor (ANN) approach to underline idea to pre-calculate the distance between the vector embedding. Then you can organize store similar vector close to each other, example cluster or a graph, so that you can later find similar object faster. This process is called vector index. Means we can upload file any PDF in a vector database like I forget the name, so where we can upload our index, means we can create a project and upload our file. So it can convert that file into two type of form. That is, one is converted into binary form called 01, or one another that I don't know, forget it. Then it can return the only approximately result, means we can search on data what we are looking. So the previous example, one option cluster example, animal, fruit and so on, query database Qdrant, you can start search by only looking the closest animal, means we can find similar type of animal using this. So let's continue with any calculation. We can start search by only looking the closest animal, not waste time of calculating the distance between all fruit and other animal object. And can start search the nearest four-legged animal, then we can the algorithm. So here you can see the example. This animal have a four-leg, kitten. The kitten have also four-leg. This can help us to find similar type of animal so quickly. So why this is so great? The above example roughly